the last thing we might have a look at is if we're going too slow, where are we going to fall off? Like, where are things going to start going wrong? And probably the first, when we're trying to work out where things are going to go wrong, we can be sure that we're safe if we're in the bottom half of the circle. Because if you go in the bottom half of the circle and you stop there, you're just going to roll back down, kind of oscillate back and forth in the bottom of the loop. So we know if things are going to go wrong, they're going to go wrong up in this half of the circle here where things get overhanging. And in fact, if you make it past the top, you're going to be okay. So if we're going around this way, if things go wrong, they're going to go wrong in there. That's the danger area. And so let's put our little roller coaster on there and think about the forces that are acting on it. What forces are acting on our wee little roller coaster?
Weight force.
And normal.
We've got Fw, and what force must we have in order for the roller coaster to be going around a circle? Centripetal. So we're going to draw a centripetal. And so the FC is what we need, and we're going to apply that rule that we're allowed to split any vector into two other vectors at right angles to each other. We're going to do this in a really counterintuitive way. We're going to split the weight force. We're not going to have vertical anymore. What we're going to do is split it into a component that is providing the centripetal force and a component that's not providing the centripetal force. And so then what we can see is that we get the component of the weight force that is providing the centripetal force gets to be less than the centripetal force. That's the point where it's going to fall off. So when that one there is bigger than the FC, that's the point at which it's going to leave the track. And we can see that the higher and higher up we go the loop, the greater and greater the component of gravity is that is providing the centripetal force. And we can do some cunning little analysis of our angles, and hopefully we can persuade ourselves that that angle there is linked to that angle there. That must be a right angled triangle. And so if that one is phi and that's 90, then that must be theta there. So that one there must be phi, eh?
True.
That one there must be theta. So you can kind of work out the angle through the circle that the roller coaster has turned, and then you can use trig to work out what that angle is going to be and work out the exact height above the middle of the circle that this disconnect is going to take place. That's getting pretty tricky and cunning.